have a 64% accuracy. And now we go to make another polynomial regression. So come here and define P2. P2 equals to polyfit of x and y and 2. We want to find a x to the power of 2 plus b multiplied to x plus c. So after it, you can print P2 to see the output. So build it again to see the output. As you can see, A, B, C has been created. Now we need to find R2 again for this polynomial, the second order polynomial regression. So I copy and paste the R square routines here, but I must change them to P2 0 multiply to pow of x and 2 plus P2 1 multiplied by x and plus P2 2, and other lines remained similar to previous polynomial regression. And again we can find the R squared error here by build our code again. So as you can see, we have a good accuracy, and the error has been decreased from 78 to 91%. And finally we make a third order polynomial regression. So define P3 similar to previous, to use polyfit x and y and 3, and here we use a by x to the power of 3 plus b x to the power of 2 and c multiplied by x plus d. We must see 4 coefficients in the output, so print P3 and build it again. Alright, we see in the output our 4 coefficients here, and now we need to find R squared error here. So we must change it to P3 and change this power to 3 to find this part of our polynomial, and then we must use P3 1 to power of x and 2, then we use P3 2 to the power multiply by x plus P3 3, and build it again to see the R squared in third order. And as you can see, we have a very good accuracy here, 99% accuracy. And as you can understand from this line of codes, as we make higher order regression, higher order polynomial regression, we have a good accuracy. To see the better result, we need to plot this polynomial in the two-dimensional diagram. So I define plt dot figure 2 and I use plt dot plot, and here I use x and poly value of p1 and x2 to find the output of this polynomial regression. And I use this type of line for this, and I added some label for it. Label equals to first order and copy and paste this line of code for P2 and P3. So right here P2 and define blue dash line, and here write second order, and here we need to change it to P3, and I use these characters for this plot, and here I write third order. Finally, we need to plot x and y. So plt dot plot x and y, and use a green color for them, equals to green, and we added some label for our plot. So add the plot title, and here I write polynomial regression results, and here I write plot.x label x and plot.y label equals to y, and we need to add some legend for our plot. So add a plot legend, and finally plot.show to see the results. I add that code here to make two plots without closing first one. So I write block equals to false, and now build everything to see the output results. We have missed title. Okay, build it. Alright, we have a two plots, and we don't need to close first to see the second. And as you can see here, we have a 4 diagram. The green diagram is our sine function, and the red diagram is a linear regression. As you can see, we have a high error here and here. Second is a second order polynomial regression. This regression has a good accuracy, but the third order fits to sine precisely, and as you can see in this accuracy is 99% for 0.5, and it's very impressive and effective. And if you make higher order polynomial regression, you have a good accuracy. So stay tuned to the next lecture.